So just to reiterate, thank you so much, Shams. It was great sharing and really engaging and active session. So as I mentioned, we have only 3 talks, so there is no coffee break between the second and the third session. And there will be a coffee break afterwards before the panel, and then will be the reception. So you have plenty to look forward to. So this is just a time to introduce our final session chair. Dr. Zemte Engin from Computer Science Department will be chairing the session on the environmental and cultural factors for One Health. Over to you. Thank you.
Thank you very much. I'm really very pleased to be here today, so thank you for the invitation, Patty. So it is the session on environmental and cultural factors in One Health surveillance. We have got 3 presentations, but 4 speakers. I'm aware that, well, it's been a long session, the previous one, so I would encourage some movement until our next speaker comes to the stage. So introducing first speaker, but maybe before that, I was asked to remind everyone, and first to my speakers, to speak into the microphone. And at the end of the session, there will be Q&A, and for Q&A, I'll ask the audience to wait for the microphone again before to ask their questions. So first speaker, Anna Sullivan from Center for Digital Public Health in Emergencies at UCL and EcoHealth Alliance in USA. So please, the stage is yours.
Okay, thank you so much. Thanks for that introduction. You all know me from the previous session, but my name is Ava Sullivan. Need I speak more into the mic? Can you guys hear me well? Okay. I just want to introduce myself for context of sort of how I'm speaking to this topic today. I'm a part-time first-year PhD student, so this is really a topic that's near and dear to my heart. It's something that I'm interested in diving into deeper. I won't be presenting sort of project results, but rather speaking around this topic as it relates to the theme of this session and the theme of the entire day. So One Health in the era of global warming, I really want to speak to my interest in anthropogenic activities as it relates to spillover risk and really thinking about how that modifies surveillance opportunities. So I will also say that a lot of this work is influenced by researchers that are in this room today, so it's very exciting to speak to this group. Emerging infectious diseases are a pressing concern. Actually, this very point is illustrated fantastically by a 2008 paper by Professor Kate Jones in the back. And despite strides in public health like hygiene and medical technology, they're an increasing threat to global health security in terms of frequency and severity of outbreaks. So this challenge is prescient. And I think really something that we learned from COVID-19 is that responding to pandemics is not a sufficient way to address this challenge. Responding to outbreaks after they occur is not sufficient in terms of morbidity, mortality, and the economic losses. In a 2021 paper, it was measured, an economic study was performed, and the findings were that global strategies to prevent pandemics were estimated at about $22 to $31 billion annually, which is 2 orders of magnitude less than damages that are produced by pandemics. So we can really understand why response is not an adequate strategy. So I really want to be thinking about ways in which we can address pandemics before they occur. And I think this is important and illustrated well by this figure on the right, where we can see that emerging viral threats are best combated as close to the point of spillover as possible. What we can see in the figure is that there's these natural reservoir hosts that are in wildlife, and points of spillover which occur either between wildlife and livestock species or wildlife directly to human species. And it's that point of, after that point of spillover, where we see amplification and spread. So averting spillover transmission is critical for that prevention element. Now, the spillover process inherently involves human, animal, and environmental interactions, and this is why I think it's so fitting to speak in the theme of this session. Genetic evolution or virological or microbiological criteria are insufficient to understand risk and zoonotic potential. So we can see that from our virological investigations into pathogen discovery, that a pathogen might be sufficient to infect a human, but exposure is needed for spillover to occur. So they may have that structural mechanism, but we need exposure to complete that spillover pathway. And human factors tend to be the most salient factors in driving that exposure. So in order to reduce the risk of disease spillover, it's important to understand how these interactions between humans and animals can influence spread. And all that is just illustrated in this little snapshot of daily life that I took at one of our study sites in India, where you can see really how much the environment, wildlife, livestock species, and humans are interacting in almost on a subtle level. We see in this picture dogs. It's a little hard to see on the screen, but we're seeing a dog, we're seeing goats, there's agricultural land, there's fragmented forest. All of these create interfaces between humans and animals that affect disease spread. Something prescient about this topic is that risk of zoonotic disease emergence is not uniform across countries or across areas. So there are many different ways of thinking about how risk is distributed, and these models relate to how we can understand what is important in terms of disease risk. This hotspot map was produced, in 2017 from a group at EcoHealth Alliance, led by Toph Allen, called Global Hotspots and Correlates of Emerging Zoonotic Diseases. And the primary drivers used in this model are that of EID risk is elevated in forested tropical regions experiencing land use changes and where mammal species richness is high. So those three factors are representative of an environmental factor, a factor related to animals, and a factor related to human behavior. So it's this true One Health topic. Through the literature, through my sort of wading through the literature and forming these questions and this space that I'm interested in, their key drivers have been identified, and I think really they're diverse drivers, but what they all have in common is that they're really at the nexus of environmental and human factors. So major drivers of emerging infectious disease are these land use change and deforestation, livestock production, and wildlife trade. And for the sake of time, I'm not going to go into the details of these, but they really do have commonalities in which humans and animals are in contact in new ways. There's also secondary drivers, which are I believe also play a large role in the amplification and spread. And people all day have been talking about their works and projects that relate to these topics. So population growth and urbanization, agricultural intensification, human travel and movement, which we all know was a huge driver of the COVID-19 pandemic, and climate change, which is a modifier of all of these. I'm going to end with a couple different models that I think are important in understanding this special opportunity to think about pandemic prevention as it relates to spillover. Risk is not a flat or singular idea. It's made up of hazard times exposure times vulnerability. And we can, as I said before, really perhaps understand the hazard. But I'm interested in sort of characterizing those exposure factors. What brings humans into contact with animals and what makes it risky? And then vulnerability, I think, is a really important element, which wasn't always part of this sort of environmental health equation, but has, I think, more and more practitioners have become aware of the importance of vulnerability as a part of the risk equation. The second model that is really a motivator for me and helps me understand risk in this way is the Swiss cheese model, which the origin story is, I think, that of aviation, to understand the complex pathway that needs to occur for an adverse event. In this case, the adverse event is spillover, and I know I'm running out of time, so what I will say is that something really exciting about the Swiss cheese model is that it presents the idea that as a group of interdisciplinary practitioners, if we're all working on this complex pathway at different levels, all we need is one solid slice for spillover not to occur. Okay, I'm getting the dreaded time end sign. So I will present you with this last slide, which is why are we thinking about behavior? And I think behavior is a real element of human exposure. I have a couple really good examples. So if folks are interested in this topic and want to come talk to me during the coffee break or afterwards, please do. Thank you very much. Thanks.
Thank you very much, Alba. And I'm sorry to sort of rush you, but that's what I have been asked to do. So, any questions from the floor, please? Yes, please.
Yeah, thank you for a really interesting presentation. You talked about behaviour a lot, but the word I didn't hear you mention institutions.
Can you please take
Sorry.
the microphone?
Yeah, the microphone. Yeah, thank you so much. Yeah, you talked about behaviour there and its important role. What about institutions? So, for example, if you think about an institution, to political scientists, for example, talk about extractive institutions, right? This is things like colonialism, which we know have played huge roles in this, for example, in sort of HIV in Africa. So where do institutions fit into what you're talking about? Or do you subsume them within behaviour? Thank you.
Yeah, thanks for the question. Well, I think in terms of drivers, institutions are huge. I think that institutions could be a protective factor or a risk factor for many of these drivers. But because it's so related, I think, to culture, it's really challenging. I will talk a little bit about wildlife trade. So the wildlife trade is a booming industry. The United States is I think, the second largest importer and exporter, or perhaps second largest importer of wildlife trade products. But making policy around wildlife trade is really hard because it's related to livelihood, it's related to culture. So it's really complex. I think, as we all know, climate change, also there are institutional, we need larger actors other than simply individuals to address all these upstream drivers. I'll also say that institutions, in terms of thinking about One Health, institutions play a big role in collaborating with each other. So to shift the paradigm from human health ministries addressing these health issues to really think broader and make sure that we're incorporating environmental health and animal, livestock, and wildlife health into that conversation is really important.
Do we have more questions? Okay, so I guess that's time to move on to the next speaker. And thank you very much. So again, apologies for my pronunciation. So next speaker is Valerio Graciano Borges from University of Sao Paulo, Institute of Astronomy, Geophysics, and Atmospheric Sciences from Brazil.
So thank you, Patty, thank you everyone for the attention. I'm a master's student at the University of São Paulo, so this is my master thesis that I've made. And for a start, and then in the introduction. So first, about the meteorology and society is a subject that is always related to the society. Since the beginning of the human civilizations, we always were searched for the patterns of nature and atmosphere. And the search of these patterns still occurs today and currently provide various sectors of society, such as water supply, aviation, agriculture, transport, and etc. And water supply is one of the most important variables that this subject, meteorology, provides to us. And precipitation is one of the greatest, I think, variables of interest in society, because it affects not only our daily routine, but also, an example is the proliferation of diseases. And in the context of climate change, when we have the pattern of increasing of temperature in the global, the area of such arboviruses and vectors of transmission that mostly was restricted to the tropical area of the globe, in the climate change context, they expand their area of presence to other areas that wouldn't there before. So talking about the Aedes aegypti is one of the most principles vectors of transmission of arboviruses, and his life cycle is mostly correlated with the water. So mostly in the eggs and larval stages of his life. And the best climate conditions to this vector of transmission is, of course, an humid tropical climate, temperatures between 12 and 36 degrees Celsius, high levels of relative humidity, and of course the occurrence of precipitation that brings water to the breeding sites. And dengue, talking about dengue, of course, is one of the most important, and let me just keep, one of the most important arboviruses in the world. So one of these characteristics, it has the serotypes, that is different responses immune that the body shows to the virus. And altogether there are 4 types, then 1, 2, 3, and 4, and of course they can cause the epidemics that are registered. So the mitigation measures for this vector of transmission is of hardly control because of his great adaptivity ability. And the geographical area of the cities and the geographical space will determine if these mitigations are efficient or not. So the main goal of my research was seek a better understanding of the influence of precipitation on the increase and decline of cases of arbovirosis, dengue, in the city of Recife, Pernambuco, evaluated together with the influence of the serotypes on the population. Talking about the methodology now, the study area, as I said, is in Recife, so in the tropical area of Brazil, in the north. The data used in this research corresponding to health data, weather data, and sanitation data to provide us information about confirmed cases of dengue, serotypes, mostly on monthly frequency, and weather data also. An analysis with a regression model was used, and the regression model explains how a variable is affected by other independent variables. So a generalized expression for a regression model is this first equation here. And for this work, we used the negative binomial regression type to try to predict the cases of dengue. And why we use this type of regression analysis? Because, of course, of the characteristic of the variable that we are analyzing. So it's cases of dengue in this case. So the cases of dengue has a variance that is much more higher than the average of the time series. Not only in the daily frequency, but also in the monthly frequency. So the models used for this work was, as I said, a simulation using regression analysis to cases of dengue, using first simulation was only with weather data that determines the cases of dengue, and the second simulation is with this weather of data, but the implementation of the serotypes DENV information on this simulation. And another simulation was used to climate simulation to provide us if we can predict and represent the precipitation on the Recife area. So about the results now, this is the monthly average for precipitation and cases of dengue, being cases of dengue the orange line and the bars on blue the precipitation. We see on this left graph that is all the time series on average monthly, and they all they correspond effectively well, but if we remove the years of epidemics, we have this second graph, which we have a much more correlated pattern, with the rainy season being the mostly high cases and the dry season the low cases. In the seasonal pattern, we see also correlated, so the first will be with the epidemic years, the second without the epidemic years, and the last with the pattern of seasonal on precipitation. And also winter and autumn being the rainy season, and which also we have the high cases on these both seasons. Talking about the classification of precipitation on Recife, the precipitation profile, we made a classification on the daily precipitation on Recife. So we have a classes of dry day, very weak, moderate, strong, and very strong precipitation. And correlating with the rainy season, which is autumn and winter, we see that precipitations such as weak, moderate, and strong are very correlated with the high cases of dengue. Analyzing the profile precipitation on monthly precipitation, we see that the epidemics, such as 20 and 2, are a day where we have a very rainy season of precipitation. Analyzing sanitation data, for the sake of time, I'll be just summarizing. For the Recife in specific, we have a good sanitation data, but the municipalities around doesn't have the same on talking about the disposal of garbage on residents. So the geographical data also show us that in the tax of 10 cases per person, we have that the Recife area is one of the greatest in all the region. Analyzing the regression analysis now, we have that this first simulation gives us this pattern, and if we add the serotypes information, the model can see the epidemics events. And analyzing the correlation between the observable data, there was an increase in correlation in the second round. Analyzing now the climate simulations, we see three simulations where the Hegi era is one of the most that mostly approximates with precipitation on monthly and seasonally patterns. Okay, so the conclusions of this work is that those precipitation explains the increase in dengue cases, and the response is yes, mostly in the monthly and seasonal patterns of precipitation. And how the serotypes affect dengue of cases is that the serotypes affect mostly on the epidemics events of the time series. The sanitation in Recife reflects the proliferation of the vector, and the answer is, for Recife, we found a good quality of sanitation, but the around areas wasn't so good, so that might affect the increased cases in the municipality of dengue itself, in Recife itself. And is public policies effective in the mitigation of vector? Of course it is, but by doing this research, we couldn't find a data that could specifically say which period mostly affect the cases of dengue, but it's a point that we have to do in mind. And for last, did the Reg CM4, the climate model for precipitation simulations, represent the precipitation? And the answer is yes, mostly for monthly and seasonal patterns, which are the two scales of time that mostly correlated precipitation to cases of dengue. That's all for now. Thank you, everyone.
So thank you very much. I think we just need to be careful about what we are wishing for.
Yeah.
A little bit. It could be at the back. So can I check for any questions from the floor? Any comments, any insights into what has been discussed? So what is the next step?
The next step
Yes.
would be due on another region of Brazil, because Recife is a tropical region. So the is next near to equator and it's a coastal line. So the temperature and the humidity doesn't vary along the year. So analyze this in another region of Brazil where we have a greater variability of temperature and relative humidity will help us to express not only precipitation, but what other weather variables would help us to understand this correlation between the cases of these arbovirus, such as dengue.
Thank you very much. So please go ahead. But yeah,
Oh, sorry.
take the microphone, please.
Yeah. Hello, Yuri.
Hi.
I've got a question for you, brother. Yeah. So, like, in your model, when you try to predict cases, do you fit temperature and relative humidity together, or are they kept separately? 'Cause
Yes. On the first simulation that was only with weather data, we used, are you guys seeing me? Oh, hearing me well? Okay. We use precipitation, temperature, relative humidity, and days of precipitation on the month. So basically, this was the weather variables that was used on the model, not only precipitation. Yeah.
Okay, because like with humidity, I remember like I tried fitting relative humidity with temperature, both of them together, and I honestly got a right bollocking not to use them two together, because they say I think relative humidity is like a function of temperature and water. So something like issue of like multi-collinearity, stuff like this. Like,
Yeah. Because the precipitation in relative humidity, they do correlate, but we are analyzing here the monthly average of relativity humidity. So the numbers on the monthly average is around 1980 on Recife, of course. And in that case, it doesn't correlate a lot with precipitation, mostly because precipitation occurs when we have relative humidity near to 100, right? So on average monthly, we don't see much of that pattern when we analyze in this scale of time. So that's why.
Oh, okay. Oh, thank you very much.
Yeah, you're welcome.
Okay, excellent. Do we have more questions, or can we just then? Thank you very much. Another round of applause, please. So our third presentation is going to be a joint presentation by Luisa Campos and Clarissa Lins de Lima from Department of Civil Engineering, Civil Environmental and Geometric Engineering at UCL and Polytechnic School of the University of Pernambuco in Brazil. The floor is yours.
So close, yes. Okay, no, we are not going to be so close. Can you hear me, guys? Yeah. Okay. So we are going to present here the water and sanitation conditions in the project area, at least one case study. Why we are doing this is we are interested to identify the hotspots, right, of where the mosquitoes are breeding, because we all know that the environmental conditions, although we know that in Brazil it's rich areas and poor areas, they all have the problem of dengue and Zika. But obviously, the poor is all vulnerable, right? They obviously water and sanitation conditions and the way the waste is managed, it helps to improve the control, right? The control of the outbreaks, obviously. So the idea of having this part in the MIWAR project is exactly to identify the hotspots for mosquito breeding, and also what are the practices associated that we could then feedback the team that is developing the app, right? Aisha and the others there, and Tiago as well, that we could, how can we improve that, right? So I will pass, before I pass that, I forgot to say, right? The questionnaire was designed by the UCL team in collaboration with the whole team, obviously. We have obtained ethics approval at UCL and also in Brazil. So we have already applied the questionnaire in Recife case study, and now we are starting applying in Campina Grande case study. Unfortunately, because of the COVID-19, we all, delayed our questionnaire, and we don't have many results to talk to you today here, but we are making a good progress. So we are gonna, Clarice is gonna present to yourself here the findings.
So hi everyone. As Luisa said, these are just our preliminary results. So our study area is Nova Descoberta, which is a neighborhood in Recife. You can see this area which is highlighted in the map of Recife. And Nova Descoberta has approximately 34,000 inhabitants, and the average monthly income is around 859.39 reais, which is the Brazilian currency. So according to the IBGE, which is our governmental institute for census data, Nova Descoberta can be considered a poorer area because, considering the minimal age per month, it's below two minimal wage per family. So this questionnaire, they were applied to 23 participants, and they were selected according to the agent's schedule. So every time the agent would visit a house in Nova Descoberta, we applied this questionnaire. And it is divided in 6 sections. The first one is regarding water supply of the household. The second one is regarding sanitation and stormwater drainage system. The fourth one is related to solid waste and disposal. These others is related, there are many things related, for example, what are the measures that they take to the population actions to avoid the breeding sites of the mosquito. And the last one was a bit more about the person who were being questioned, like their gender and their salary and those things. So from the results so far, regarding the water supply, most of the responses, they said that they do have a water tank in their household. These are an example of water tank. I mean, it's very common in various areas in Recife, because many of the population do not have a regular water supply. So, for example, they can spend up to 15 days without running water in their pipe, and they have to store the water until the system is regulated. So they do have this blue disposal, like blue tank right there. Sometimes they are disposed on the floor. Sometimes it's up at the top of their houses, and these are the way that is mostly common to store water. However, we can see that not everyone properly covers those waters. So what they store them and they leave like inappropriate lids, which in this case is not actually the most appropriate one. So in these cases, the mosquitoes, they can deposit their eggs there, which can in the future hatch and turn into larvae and, you know, increases the mosquito density in that area. When it comes to the observation of of mosquitoes in stagnant ponds, most of the responses were positive to that. They also very frequently they observe mosquitoes in the open drained tunnel of their burrow. So it's something that is very frequent to see. And mostly of the storm water, they are drained straight to the streets. And actually, in so many cases, there are many flooding in Recife, so there are many points of the where the rainwater after it is accumulated in certain spots of the houses. And when it comes to these other questions of what the measures that they take to prevent the outbreak of arboviruses, the most common one is like they cover tightly the water containers. It's quite a contrast with what we saw in the first slides because they say they cover, but we can see that it's not up to 90% of the people who does cover their water tank. The other frequent measure that they take is to use mosquito repellent to actually provide to get infected with the arboviruses. And they usually add larvicide to their tank water. I mean, when during outbreaks occasions, the agents, they guide the population to add larvicide at their own water tank. So the conclusions we can have is this pilot study, they can help us to comprehend a little bit of the reality in Nova Descoberta neighborhood. I mean, although the number of people participated in the questionnaire was not high, was not a lot, but we can have how can I say? We can have an idea of how the reality is. It can guide us also to identify the practices of the community and how this practice are favorable for the mosquito reproduce, the mosquito breeding sites and to mosquito to reproduce. And it can point out also the deficiencies in sanitation and water distribution that can be associated with mosquitoes proliferation. And we can also speculate that water and sanitation practices in Nova Descoberta are exacerbating to the mosquitoes' proliferation. Thank you very much.
Thank you. Thank you so much.
So that's 1 minute earlier than.
Good. Good.
So questions, please. Let's start from this side.
Lots of questions here. Wow, you like. It's almost end of the day.
Thank you very much for the nice presentation. I've got a question. Out of this kind of like the four parts of the infrastructure, water supply, sanitary system or sanitation, and also the urban drainage system, and also waste management system, which one do you think has got like a more impact on the disease actually in your case study? Thank you.
Yeah, thanks so much. Yeah, we haven't done an analysis yet. Our plan is to do a statistical analysis, and if we can also look into the outbreak numbers, right? The cases would be better for us to understand. But we haven't done any analysis yet. And also we plan to run a workshop with the stakeholders, right? Now in November, that has been delayed so that we can learn more about that. But we don't have that answer. Which aspect is influencing the most on the outbreaks? Well, from what we observe, I would say that waste management is one of the key factors. You know, if in Brazil, I think Clarice can respond that better than me. I'm Brazilian, right? And I used to live there. But having, you know, if you have a plot that is not well looked after, and they throw rubbish there, and that is a way for mosquito to be, you know, to be developed. So I think that it's key management, and obviously I would say that water as well, stagnant water. We used to have lots of fountain and stuff like that, but now I think most of the place has removed to avoid. Otherwise, you have to treat with chlorine.
Thank you, sir.
Thanks for the great presentation. It's a great project. I saw that a lot of the questions on your questionnaire were related to practices around mosquito control and how people cover their items or things like this, or how they remove them. Did you have any investigation into the knowledge that these community members held around mosquitoes' ability to transmit these diseases? Some of the work that I've done on Nipah or something like this, community members aren't aware that the bats are transmitting these diseases. So I'm wondering if you have a sense of whether that there's a uniformity among the knowledge about disease transmission from mosquitoes.
Thank you so much for that question. That question would have been answered in our focus group that we haven't run with the community. We had planned to run focus group with the community to identify if they have that knowledge and how they perceive the risk of, you know, if you leave if you throw away a tire, for example, it's a common practice, accumulating tire or any empty bottles. So if the community have that perception that they are increasing, you know, their exposure, right, to the risk, but unfortunately we haven't done that. Thank you. Hope to do in future.
Thank you very much for an excellent presentation. So my original background was in WASH, so I've done quite a lot of work on measuring behaviour. I wondered, have you tried any different approaches to actually obtaining the data? So, for example, using standardised tools or other types of things like structured observation to observe people's actual behaviour and compare that with how they actually report their behaviour?
That's a good point. However, because of the way the project has been run under COVID, it has been very difficult. Would be ideal for us, for example, to run a transit walk, right, for us to observe the local practice there by the community, but unfortunately did not happen. The easiest way for us how to enter in contact with the household was through the health agents, who have a routine from household to household. Thiago can say that better than me. For us to apply the questionnaire, but it would be ideal for us to do the observations that you are pointing out. Yeah, it's a good suggestion. Thanks so much. We can have a chat about it. Thank you.
I think we have a person
Yes,
here.
I've got a question for you folks.
Me?
Yeah, both of you actually.
Okay.
Yeah.
Clarice, Clarice.
Yeah, because the images that you showed, it has also a very stark parallel to, like, you know, places that I have a strong affinity for in sub-Saharan Africa, like Ghana and Nigeria. It's an unfortunate reality there where we also have, you know, like barrels, which sometimes we don't kind of cover, which is a source for, like, you know, infestation for, you know, the Anopheles mosquito, where we have malaria, etc. But also, like, in terms of waste management as well, like, the way we dispose of wastewater, especially like in urban places here, like on the sides of the streets, they are uncovered, which we call gutters. And that's where most of our offensive material go, and it's actually exposed, which also serves as a source of, you know, infestation too. I was wondering if this awful reality is also present in urban parts of Brazil, like having gutters on the side of streets and where wastewater is also disposed there. That's my question.
You want to ask? Ele quer saber se no Brasil tem os esgotos correndo na rua também.
Oh, yeah.
Se tem isso.
Yeah, so this is a reality in some parts of Brazil too, like open, how can I say?
Open drainage, yes.
Yes. Yes, it is a reality in Brazil too.
So is there any kind of action that is being taken to try and seal them, like any quick kind of action, or is it just something persistent kind of thing?
Well, the action is this provision of water and sanitation. Brazil serves in terms of water supply is quite good, although the region north, up in the Amazon there, it's the most that is not 100% supplied by clean water. But most of the capitals in Brazil, they all have drainage, sewage drainage, and clean water. But on the informal settlement is a problem, I would say. So we would see that running waste on the roads or on the streets.
Thank you.
All right, thank you very much. So with
Thank
that,
you.
we should really close the session. So thank you again.
Thank you.